What's going on, everyone? This is Don with the Physics Instructional Resource Team, and I've got another demonstration for you here today. This is called the Helmholtz coil and vacuum tube, otherwise known as the E/M apparatus. And what this is basically two large coils with 132 turns each. They're made of copper, and they're hooked up to power in such a way that the magnetic field between them is going to be very straight, very uniform, and pretty strong depending on how much current we put through them. And what we've got in between them is also this vacuum tube with an anode and a cathode, which will allow us to create an electron beam depending on how much voltage we are putting through the vacuum tube. And basically I've got these controls back here which let us control the accelerating voltage right here and the coil current right here. And basically we're going to look at the interaction between the electron beam, which is essentially just moving charge, which is a current, and the magnetic field. And when we adjust these variables, we should see that the motion of the electron beam will be affected. And so I'm going to turn off the lights after putting this backdrop here. Well, first I'll put this backdrop here. I'm going to look at the beam up close. Then I'm going to turn off the lights. I'm going to turn up the light settings on the camera. And then I'm going to increase the accelerating voltage. And somewhere around 250 to 300, we should see the beam appear. So I'll go up to 300. And so we should see this electron beam pointing downward. And if we do the right-hand rule, where the velocity of the beam is pointing down, and I've got the current hooked up so that the magnetic field is pointing towards you, what should the direction of the force, the Lorentz force, be on the beam? And actually it turns out we can just do this experimentally. I'm going to increase the current here. You should see as I increase it, it starts to curve a little more and more and more, and we get this counterclockwise circular motion. And circular motion is neat because we already have an equation for that from Physics 1. And we can relate all of those variables to all of the electrical variables. And so as I reduce the current, there we go, the circular motion path starts to widen out a bit. And also, if we mess with the voltage, if I increase the voltage, that initial velocity gets bigger, so the circle gets wider. And if I decrease the voltage, it does the opposite, all the way until the beam disappears because the voltage isn't enough to create the beam at all. And so this is the Helmholtz coil E/M apparatus. Take care.